We're explaining how to access and use 2D arrays in 8086 assembly language. 1. Understanding the basics. A 2D array is essentially an array of arrays. In 8086, memory is linear, so we represent a 2D array as a contiguous block of memory. Think of it like a grid. Each element has a row and a column index. To find a specific element, we need to calculate its memory address. 2. Calculating memory addresses. Let's say we have a 2D array named myArray with rows and cols columns, where each element is a word, 2 bytes. The base address of the array is stored in a register, let's say bx. To access the element at row I and column j, we use the formula address =bx plus icols plus j 2. We multiply by 2 because each element is 2 bytes. The icols part calculates the offset to the correct row, and the fa plus j part offsets to the correct column within that row. 3. Example. Let's assume rows is 3 and cols is 4. The base address of myArray is in bx. To access the element at row 1, column 2, remember we usually start counting from 0, we would do the following. I =1, j =2. Address =bx plus 14 plus 2, 2 =bx plus 12. This means the element is 12 bytes from the base address stored in bx. We would then use this calculated address to load or store data using instructions like mov. 4. Loading and storing data. After calculating the address, we use assembly instructions to access the data. For example, to load the value at the calculated address into the AX register, we'd use mov ax, bx plus 12. To store a value from AX into that location, we'd use mov bx plus 12 AX5, code example, illustrative. A complete code example would involve setting up the array in the data segment, initializing the rows and columns, and then using a loop to iterate through the array and perform calculations or manipulations on the elements. The loop would involve incrementing I and j, recalculating the address using the formula, and then using the mov instruction to access and manipulate the data at each location. This would require using the appropriate registers effectively and managing memory addressing carefully. Remember to handle potential out-of-bounds errors in your code. 6. Advanced techniques. For larger arrays, you might optimize memory access by using more sophisticated addressing modes or employing techniques to improve data locality. You might also use different segment registers to handle addressing beyond the 64 KB limit of a single segment. These concepts form the foundation for working with 2D arrays and can be extended to more complex data structures in 8086 assembly.